In this video, we're going to talk about quicksort and merge sort. So we've already talked about doing the bubble sort, the insertion sort, and the selection sort, and all those were big O of n squared. So now we're getting to two algorithms that are as fast as theoretically possible for comparison-based sorting algorithms. Okay, that's going to be an n log n. And again, you'll learn more about what all those numbers mean or what all those phrases mean when you get to algorithms class. Okay, but for now, just know that these two are the fastest we can do. Okay. So we're going to start with quicksort, and quicksort is going to look a little bit like the binary search in that we're going to, but to sort it. So we're starting with an unsorted list. Okay. And as long as the list size is greater than one, then it's still potentially unsorted because, of course, a list size of one is sorted by definition. We're going to partition this list into two sublists. We call them lower sublist and upper sublist. We're then going to recursively run quicksort again on that lower sublist and on the upper sublist. Okay. We're going to keep doing that. And then our base case is going to be when we get down to that one element size of one. Okay. Then we start combining those back in to the sorted one list. Okay. Which basically is how that works. Okay. So the pivot that we're going to separate or going to partition. Okay, so partition is a term in computer science. It's not talking about sorting. It's talking about taking some value and dividing up the array into those less than and greater than. They're still not in order, but they're ordered kind of. It's kind of a first attempt at ordering. Okay, so lots of ways to determine the pivot that affect the performance of quicksort. Okay, but we're going to just take it to the middle. We're going to assume that the middle element of the array will be our pivot point. Okay. So because it's visual, I'm going to go ahead and share from a PDF of the book just so we can see some of their graphs. Okay. So for example, here we have this list. Okay, 45, 82, all the way to 92. It's not ordered. Okay. So if we look at the middle position, again, calculating the left and the right to see where the middle's at. The middle's right here at position 4, okay, which is 50. Okay. So when we're done, we want 50 to be in the middle with all of the elements less than 50, the 32, 25, and 45. See, they're not in order, but they're all less than 50 on one side, and all the others to the right of that. Okay. So the pivoting, it looks like when we're doing it like this, that you make the pivot the first element. Okay. And then as you move through, you're going to assign things either to the lower or the upper sublist. Okay. So this small index here is going to be right there. The index over here is going to be for the things we haven't moved yet. So you pick an item here, you either move it to there and move the small index, or you leave it where it's at as you're going through. Okay. So then when you get done, it doesn't show up when it's done, but when you're done, you're going to have to pivot all that's less, all that's greater than or equal to. Okay. And then you move the pivot to the one plus a small index. Okay. It's basically how it's going to work. Okay. I'm not sure. Yeah, I guess that, no, it hasn't finished it yet. There's the swap we do. They're still getting there. They're showing it one by one. Yeah. So like the 66 here, it's going to move. This upper sublist is going to move over one because it's bigger than it needs to be. In fact, that one is until it gets to the 45. The 45 gets moved back over to here. Okay. No, it gets moved to here. Sorry. And then so they don't show it yet. Oh yeah, they do. So when we're done, so we've now got all of the array. There's no more gold left. They're either this teal or this purple. Okay. With the pivot at the beginning. Okay. So we're then we want the pivot to be in the middle. So we're going to swap it with the element that small index points to, which gets us to this. Okay. So this is what it looks like in the first division. Okay. You would then do quicksort on this 45, 13, 32, 48, 22, and 11, and recursively, and then also do it on this half. Okay. Keep going down. So you just have two elements left. Okay. So as far as the code goes, we'll do the code actually on the server. Okay. So I'm going to pause the video a second as I didn't log in. Okay, I'm on the server now. So I'm in my search directory. So I'm just going to start this file called quicksort.cpp. We may want to combine it with something else later, but this will get us started here. Okay. So we have to write several functions to get this to work. Okay. We're going to start with a function for the partitioning. Okay. Right window. So we have our template class elem type. Okay. And I'm going to have to do that more than once. I'm going to go ahead and copy that one so I can do it again. Okay. The partition is going to return an integer. So we have the partition. Okay. We have the elem type. This should look like the other ones we've done. Okay. List. Okay. And we're going to have an int first and an int last. Okay. That's going to track the current version. Again, we're going to be calling this on multiple parts of our array. Okay. We're going to start creating a variable type for the pivot. Okay. That will be of type whatever we have a array of. Okay. We're also going to create an integer on the small index, which is going to track that line that's moving that divides the small things that are smaller than the pivot and things that are bigger than the pivot. Okay. Then we're going to start here by moving. So the swap function, which we haven't done yet. Okay. We're going to take our first element. Okay. And we're going to swap it with our midpoint. Okay. So the midpoint is going to be the first plus the last divided by 2. Okay. So that's going to take that. Our pivot is going to be the midpoint, the first plus last divided by 2. We're going to swap it out to the very beginning. Okay. And we'll write that swap function in a minute. Okay. And then we're going to say the pivot then is equal to the list at what is now the first position, what would have been the midpoint before. Okay. And then we're going to start here with our small index being equal to first. Okay. That's where we're going to get started. Okay. We're going to do a loop now. We're going to say for int index is equal to first plus 1. Okay. So first is where the pivot stores. We don't want to be at first. We want to move to 1 to the right of that. Okay. As long as index is less than or equal to last, so we're still in range, index plus plus. We're going to move through the array in this fashion. Okay. We're going to say if the list at position index, if it's less than the pivot, okay, then we're going to make the small index go up by 1. Okay. And then we're going to swap. Again, that takes the array we want, list, the small index to index. Okay. And then in either case, okay, when we're now out of the if. Okay, we're now also out of the for. Okay, when we're out of everything, we're going to swap list first small index. Okay. And that's going to partition us. Okay, that's going to get us that last one there is what puts the pivot back in the right spot. Okay. So we're basically going through every element, starting with the first plus. So we move at the top, we move the middle element to the first element. Okay, so it's in position 0. We're going to start at position 1 and go through until we're at the end. And for every element, we're going to see if the index is less than the pivot. We move that small index once, and then we're going to swap the small index and the index. Okay, then we're going to keep moving. Okay, and this should get our partitioning done. Okay, so let's look at that swap function next. Okay, so I can pull in. I thought I just did my. That's weird. Oh, that's because I tried to do it twice. Try to kill twice before I yanked. That was the issue. Okay, this next function is going to be the swap function. Take a look at it. Okay, so it's a void function, swap. It's going to take a array of element type. It's going to take an integer first and an integer second. Okay. And like we've done with swaps in the past, we're going to have to create a temporary element to hold things and then just move things around. Okay, so we're going to say element type temp. The temp is going to be equal to list at that first position. And then list first is going to be equal to list second. And then list second is equal to what first was, which is temp. Okay. So that ends our swap function. Okay. So now we're going to recursively call the quicksort. Okay. So we can go ahead and create that function. Then we're going to have to create one more non-recursive function to kind of get it started. Okay, so we'll get that here in a second. So let me go ahead and I keep doing Control K when I want to do Control Y, but there's nothing there. Yeah, that's right. Control K, Control Y. Control Y. Okay. So now that we have the template, we can worry about this function. We're going to call that our recursive. So REC quick sort. Okay. Which takes an element type list and an int first and an int last in this case. Okay. So we're going to have this int on the pivot location. Okay. Then we're going to say if first is less than last. Okay. So this is what we expect. We expect first to be bigger or smaller than last. Okay. As we keep progressing, calling this recursively, this is going to be when this is no longer the case, that's our base case and we're done. Okay. When the first becomes equal to last, as it keeps moving forward, we know we've covered everything. Okay. So we have our pivot location is equal to the partition on list first and last. Okay. And then, so this is our recursive step. So we're going to call rec quick sort again on list first and our pivot location -1. And then we're going to do our rec quick sort on the list and pivot location +1. We start there, going to last. Okay, that's going to kind of cover everything. Okay, and that's going to end our current. Okay, so interrupted by the dog, as sometimes is the case. So we'll continue on from there. Okay, so we have our quick sort, the recursive version. Okay, so now we just have to go through and and kind of basically get things started. Okay, so again, if I can do it correctly, yes, Control I, finally. Okay, then I can do the quick sort function here. Okay, which is going to have a void function called quick sort, which takes again the element type list, so array of element types called list. Okay, and then a length. Okay, because we'll know the length, we won't necessarily know the first and last. Okay, so we're going to use this function to get things started. Okay, so then we have we're going to call rec quick sort on the list at 0 is the initial. Okay, and the length -1 is the initial last. Okay, and we do that because we have to make the recursive quicksort generic enough to be able to start from any portion of the array. We have to have this other function that gets us going. Okay, so that's kind of why we have to do just this first time. And once that gets us in, then we're okay. Okay, so as far as testing it, I'll leave that to an exercise that you can do to test to make sure this works. I can do a quick G++ on it just to make sure that I don't have any horrible typos. I probably do. I have something line 21. Take a look at line 21. What's at line 20? Oh yeah, that's this is an int function. Okay, so what am I missing that we're returning? Okay, so that's going to be in partition function. Yeah, I may be missing more than one. On this line, after we do this, we're going to return that small index. Okay. Let's see if that was it. Oh, it's not 2 words, it's 1 word. Okay. This is all in the book, by the way. Yeah, now we still have a main, which is okay. Okay, so that's going to take care of quicksort. Okay, fair bit there, but hopefully that makes sense. If not, the book goes through a good explanation. If not, you can always ask questions. Okay, now I'm going to pause for a second and then we'll talk about merge sort. Okay, so the next the next sort we're going to talk about is merge sort. And the quick sort, depending on how the partition, how you pick the pivot, and a lot of factors, in the worst case, it's still at n squared like the others. Okay, but in the average case, it's n log n. So this last one we're going to talk about is the merge sort, and the merge sort is always at n log n. Okay, so there's some pros and cons we can talk about why you pick one over the other, but this one's a little more complicated to figure out how we're going to code it. Okay, so again, I'm going to share the textbook so you can see the images from it. That's the best way to go. It's a little better size for that. Okay, so the idea behind merge sort, you're going to start by calling a divide function. Okay, and we're going to do this on linked lists just to see how that would work. Okay, so we have this array. We're going to partition it like before, but just square in the middle. So we totally avoid that whole process of partitioning where things go. Okay, we're just going to say we're cutting it in half, we're cutting it in half again. Okay, all the way till we get down to 1. Okay, so this is much simpler than with the quicksort, but the complexity comes, we have to merge them back together. Okay, where we start, when you have the 2 here, we say, you know, they're keeping track of what's at the beginning here, what's the smallest. So the smallest of these 2 is 28 and 35. When we get to merging these 2, we have 28 the smallest of the left-hand side, 18 the smallest of the right-hand side, and we'll pick the smallest of those 2. And finally, we merge them all back together. Okay, so it shows us here the general algorithm, which is down here at the bottom. Okay, if the list of size greater than 1, we can divide it into 2 sublists. merge sort the first, merge sort the second, merge the first and second back together. Okay. So it's going to be a recursive algorithm. And again, note that we're dividing, we have two, that we leave this kind of, we leave this running in the background, what we call another one to divide, another one then to merge, and then merge and merge. And then only when the merge happens, do we close these two back together. Okay, kind of it collapses back down as recursive algorithms do. Okay. So on the divide, so here we have, for example, a linked list, okay, of unsorted elements. Okay. So we have the head pointer. Okay. And what we're going to do here, okay, we have to find the middle of the list. So we're going to do that with two pointers, the current and this middle pointer. Okay. So we're going to do that by, as we're moving it forward. Okay. We're going, as we move current, we're going to move middle half that many times. Okay. So every time that we advance middle by one, okay, we're going to advance current by one and then advance current by one again if we're not at the end. Okay. So that when we get done, we'll have current at the end and middle in the middle. Okay. Because we don't know in advance. Okay. So we start current and middle here. Current moves forward. We're not at the end. Current. Then when we move middle up one, we're going to move current up one and then one more since we're not at the end. That'll get us to the middle. Okay. And here's, we divide it into two sublists. Okay. So we create another list with our list, our head and the other head, and we're going to break it up there. Okay. And this gets us to the following code for the divide list. Okay, so I'm going to go ahead and switch back, and well, let's see, we've got some more pictures here, I think. Yeah, and then the merging, we have the two lists. We're going to put them into one list. Okay, with a lot of new variables going on there. Okay, so this shows how we're creating that. Okay, so now let's go back over the code. We can start working through the code. Okay, so we're going to start with this divide list function. Okay, so note for this to work, we have to move over the unordered list stuff, the abstract data type and the one that implements that. Okay, so the linked list ADT and the unsorted linked list has to be moved over, but you probably already moved those over before. Don't know what it did. That's what it did. Okay, so we assume that that's there. Okay, so on this divided list, so again we have my control Y still there. It is not. So my kill ring is empty set. So I'm types again template class type. They use LM type sometimes, and this type sometimes. So well, let's go along with what they're doing. Although I like consistency. Okay, so this first function here. Okay. And we're adding this, you know, I see what they're doing now, which makes more sense. And I didn't pull this over, so we're just going to do it in and of itself. But these functions are going to be added to the unordered linked list file. Okay, I've got them separate and they shouldn't be, but we're going to be part of that class so we can get access to all that stuff. Okay, so when you're doing this, you'll have to do it that way. So we're adding this to the unordered linked list file. Okay. Okay, so that's where it's at. So we have divide. That's why you'll see in the book it has this unordered linked list type. That's why it's called type too. Makes sense. That's the namespace of this function. Okay, and I can go ahead and leave that in there just so it's clear that that's what we're doing. Okay, that's going to blow up when I compile it on this program, just so we know. So we have divide list. Node type. So again, you won't have to include unordered list because you're adding this to unordered list. Okay. So that's the node type pointer called first. one, then another node type pointer called first two. Okay. So we're just passing along the divide list. We know what list we're dealing with, linked list, because we're calling it from that linked list. So there'll be a this in essence. Okay. So we have first one and first two, which are two different pointers. Okay. So we're going to create another node type pointer called middle. And one more called current. Okay. Got an if here. If first one is equal to null pointer. Okay, that means the list is empty. We're going to let first two also be equal to null pointer because there's nothing there. You can't subdivide nothing. Okay. Else if first one link, okay, so the link to the first element is equal to null pointer. Okay, what would that mean? That would mean that the list only has one item. Okay, that it's that we know that there's at least one item, or we wouldn't be to the else with it. The if would have caught it. But that first item immediately links to a null pointer. Okay, there's only one item for that. Okay, in which case we're going to let first two be equal to null pointer again. Okay, you cannot subdivide a list of only one. We get to the else, we know we have at least two elements. Okay, that's good. So we're going to let middle be equal to first one. We're going to let current be equal to first one link. Okay. So then we're going to have an if statement here. If current is not equal to null pointer, so we haven't reached the end, then we're going to advance current one more. So current is equal to current link. Okay. So that set us up. And then we're just going to keep doing this. Okay, so while current is not equal to null pointer, we're going to reset our middle to be equal to the middle link. So it's going to follow that link. It's going to move forward one. Current is going to be equal to current link. Okay. And then as long as we're not at the end, so if current, we just moved it to the current link. If this is not equal to null pointer, then we're going to move it one more time. So current is equal to current link again. Okay. That's going to end our while. And when we're done, middle should be in the middle and current should be at the end. We don't care about current. Okay. So then first two is going to be equal to middle link. Okay. That's the first node of the second sublist. Okay. And then middle link is now equal to null pointer. Okay. That's setting the link of the original node. We're now terminating at middle. We have the new one called first two. No, that's why we passed along first two as a reference variable. We passed that by reference. So we're making side effect changes to that. Should be equal. Okay. So that ends our else. That ends the whole thing. Okay. So what this is going to give us, it's a void function. It doesn't return anything, but it's going to calculate. We're going to have our so our original linked list is now been subdivided. When it gets to the middle forms its own list at first 2 at that memory position. Okay. And the original list terminates at that middle position. Okay. Which is the first thing that we needed to do. Okay. So in moving on, after the divide, we can now worry about merging them back together. Okay. And look at the code for the merge list. Okay. Again, this code would normally be added into the unordered list. Okay. So I'm going to go ahead and actually hopefully save some typing by copying both of these lines. Maybe we can reuse some of that. Okay, so we have our template class type. Okay. And it's not a void. This one is a node type pointer. What it returns. Oh, there we go. And it's in the unordered linked list type position. Okay, this is gonna be called merge list. Okay, and merge list has a first and a second as well. Okay, although neither one need to be reference variables. Okay. So node type it's going to return a pointer to that. We're in the unordered link type namespace. It's merge list, and it takes 2 node type pointers, first 1 and first 2. Okay. So now we're going to create some new node type pointers. First one called last small. Another one called new head. Okay, so again, we're testing to see if the first sublist is empty. So the first one is equal to null pointer. Okay. We're just going to return first 2. Okay. This will happen when we're combining into our new list. If we run out, if we take all the elements out of the left of the 2 or the first of the 2 sublists. Okay, if they're all done, it's going to return the rest. Okay, because we don't have to do anything, no more work to do there. Okay. Else, if it could be that the second list, so if first 2 is equal to the null pointer, okay, then we're going to return first 1. Okay. Else, we still have some elements left in both. Okay, so we're checking to see if first info is less than the first 2 info. Okay, so again, this is where we're merging the 2. So we have 2 lists, first 1 and first 2. We're looking, and they're sorted by this point. So it's either they're broken all the way down. By the time we're merging, they've broken all the way down until they're only 1 element, or they're a subgroup that's already sorted. Okay, that's what we're checking for you. So we're looking at first 1 versus first 2 to see which one is smallest. Okay. And if first 1's the smallest, then our new head. So we're starting this is going to be the pointer to the new linked list we're creating. Okay, it's going to be first 1. And then first 1 is going to become first 1 link. So we're moving the first in the first list the first element in the first list is moved to now the new head. So we're now advancing the first list, that left-hand list, over by 1. Okay. And then the last small is now equal to the new head. Okay. So an else here means that it's not the case that the first is the smallest. So in this case, the item in the second list, that first 2 list, is smaller. Okay. So now new head is equal to first 2. Okay. We're going to advance forward. First 2 is equal to first 2 link. And then again, last small is equal to the new head. Okay. So this deals with the first position of the new list that we're creating, the new merged list. Okay. So we now have to worry about all the rest of the elements. Okay. So we have a while list. So while first 1 is not equal to null pointer, and first 2 is not equal to the null pointer. Okay, so we have some stuff, basically, is what we're saying here. We're not full yet, we're not done. Okay, so while that's the case, we have very similar stuff. I think we can cut and paste what we did before. Okay, we're doing this again, except the new head won't be the same. Okay, so I'm going to go ahead and copy this. Save ourselves a little time. Copy, then modify. Okay, so that's going to go down here. And if you find an Emacs that your spacing's messed up, just go back and hit the tab key, tab and down, and that will fix all of that. Okay. So make sure we're doing this. We're still checking to see if the first 1 info is less than first 2 info. Okay. We're not actually doing anything with the head at all. Okay. In fact, these aren't that similar. So we'll just kind of delete these. That was the same, but the rest is not. So I didn't save as much time as I thought, but we'll be okay. Okay, so if this is true, then we're going to let the last small link be equal to first 1. Okay, and last small is equal to last small link. Okay, so this is assuming the first one is the smallest, so we're adding it into the proper position. Okay, and then we're going to advanced. First 1 is going to be equal to first 1 link. Okay. Now, what is going to be similar, I think, we'll try it again. Oh, didn't need to do that, but okay. Under the else, get rid of that guy. So this should be the same thing, except where we have first 1. I just want to have the wrong number of things there. Okay, so the last small link is going to be equal to first 2. The last small link is still going to be equal to last small is equal to the last small link, and then both of these we're going to advance the other side. Okay. So that's done with our else. Okay. We're going to end our while here. Okay. And then down here, we're going to say if first 1 is equal to the null pointer, that means we finished. So the first 1 sublist has exhausted before the second one. Okay. So if that's the case, we're going to let last small link be equal to first two. Okay, it's gonna, and again, those are all in order. The sublists are in order. So we're saying that when we're pulling them, you know, one at a time, which one's the smallest from the first and second sublist. This is saying the first list is exhausted. So the whole other list is the whole second list can be added in just right there. That's what we're doing here. Okay. Else. Okay. Else will be if the second list is exhausted, I'm going to let last small link be equal to first one. Okay. And then what we've been creating this whole time, okay, I want to return the new head, which will be the new merged list. Okay. That ends the else, and that ends the merged list. Okay. So again, this is, think of the picture in the book. We have two sublists, each of which are sorted by this point. By the time we're merging, they're sorted. Okay. We're pulling the smallest of the two sublists small. Okay. So they both have a smallest element. We're pulling the smallest of each one every time through. That's what the while loop does after dealing with the first one. Okay. When one of them is exhausted, then we just move the whole rest of the other one over. Okay. So we've now got the merge, the divide and the merge together. So now, just like before, we're going to have a recursive function to set things up. Okay. And then finally our non-recursive or our recursive function to do the sorting, and our, we start again, a recursive function to do the sorting, and then finally a non-recursive function to get things started. Okay. So the next thing we need then is our rec merge sort. Okay. So again, we have our template class type. Okay, and I know I'm gonna need at least one more of those. I think just one more. Yank that one back there. We'll use that for the last function we're gonna do. Okay. So then this is a void function. Again, all of this, just so we're clear, all of this should be in the unordered linked list file. Unordered linked list.cpp, which you'll copy over from your list directory. Okay. That's a type. That's the namespace it's in. And again, if you used the prototypes and the namespaces in your unordered linked list, and you'll do it just like this. If you just did like I've been doing and just did the functions directly at the top in one spot, then you don't need any of that. You can just go directly into this next element type. Okay. And that's just going to be the recursive merge sort. Okay. And it takes a node type pointer, node type pointer. Okay, we're passing it as a reference head. So even though it's a void function, it will make a change to that memory address. Okay. So this one, we're going to create a node type pointer called other head. Okay, it's going to be the other list that we're going to create. Okay, we've got if head is not equal to null pointer. Okay, so if the list is not empty, we're going to say if head link is not equal to null pointer. Okay, so this if is going to get us, we're now where the list has more than one node. Okay, we're first going to call the divide list on head other head. Okay, we're then going to do the recursive merge sort on head. We're then going to do the recursive merge sort on other head. Okay. Then finally, we're going to do the head is equal to merge list on these two halves, the head and the other head. Okay. Into that. Okay. So this recursive algorithm, again, we hit the base case when the two conditions are not done. Okay. So if either the element has 0 or only one element, okay, then we don't have to go through all this. Okay. Then it's gonna take care of things for us. Okay. So the last thing we need to do now then is the function to get us started. Okay. Again, this is a void function. Again, we have our unordered linked list type. Okay, that's where it should go. And this is just the merge sort itself. Okay, takes no parameters. Okay, that looks weird. Why is that weird? That looks weird. Oh, that's why. Because no, that should be there. Yeah, I'm not sure why it's not lining up. Am I missing? That's what I'm missing. Yeah, I put one more if in than they did. One more set of brackets. Yeah. Okay. So in Emacs, if your spacing's not right, then you've made a typo somewhere. Okay. So the merge sort then is just going to call the recursive merge sort on first. First comes from the unordered linked list. Okay, that's the pointer to the first element. Okay. And then we've got if first is equal to the null pointer, then last is equal to the null pointer. Okay, else last is equal to first. And while last link, that gets us back to the first, is not equal the null pointer. This is just recreating the list. Last is equal to last link. That and that. Okay, so that's a little more complicated. Okay, so it's certainly worth looking through the book, at those diagrams again, go through the code as you're doing it, watch the video again to get an explanation. You should understand how both of these two sorts work. They're really important sorts. So the two sorts you're going to use time and time again, okay, in order to do your sorting. They make a lot more sense than the other ones we talked about because they're faster. Okay. So that was a lot. It's a long video. So hopefully you've made it through to the end. But if you have questions, let me know.